All right, guys. Kate, just give me a second there. All right. I'll share my screen as well. Tell me when it's visible to you. All right. So hi, everyone. Welcome to another speaker session that we regularly host here at Insaid. I hope everyone's doing great and you're having a wonderful morning. Because for me personally, I'm having a wonderful morning as well. Because today we are having a speaker. While introducing her, I'm also very excited because me myself, I've been exactly where you guys are, listening to her speak. And now, today, I've got this opportunity to actually introduce her as a panelist of that same session. So, yeah, let's get right to it. So, today, we have with us a speaker who is not only someone who can teach you a lot about data science, right? She's someone who can teach you about being that mentor out there for the community itself. So, she started sharing her journey and sharing her knowledge a while back. And because of that, she's not only a wealth of the knowledge that you can gain from her, she's just become a staple example of a great personality in this community that she has grown to really appreciate. And for that, no, we should all appreciate her doing this because this is she's doing for the community and upskilling everyone around her. And as you have gets so far, I'm talking about none other than Usha Rengaraju. Or for the people who are coming here from Kaggle as me, you will also know her as the Tensor Girl. So let's give her a warm welcome and let's get right to the session. So hi Usha,
Yeah,
here's for you.
hi, yes, thank you so much for the kind introduction. And thank you
No
so
worries.
much to the Insight team and yourself and Ashish for the invitation. It's my pleasure to be part of this session. With this, I'll start sharing my screen.
Yeah, sure.
Yeah. So,
Yes, it's visible.
yeah. So today's topic is going to be about AI for climate change. And so the climate change is a problem which is one of the United Nations 2030 sustainable goals. And it's one of the most important problems which is plaguing the society in humanity in general as well. And so what happens, general definition for climate change, if people have not thought through this and things like that, I've just put a refresher of the definition of climate change here. So if there's going to be a long-term shift in the temperatures and weather patterns, this can cause a lot of problems. So it can cause the economy as well. It's not just about temperatures and it's not about the weather patterns just being there, and because these are variables which are interdependent and which affect a lot of other variables and parameters, the most important of all, economy as well. So for example, if you have a very high temperature, so if the temperature in generally certain cities are 40, but what if it reaches 50? And what if it reaches a huge amount that people even can't get out of their houses? So the economy is going to get impacted, right? And if you're going to have huge temperatures, then there are other parameters in the environment which can get affected, like you might, it might disrupt the rise of water and other things, which in turn can collapse the cycle which is happening. You might get a lot of flood suddenly in certain areas. And so there are other natural parameters which can get affected. There are human control parameters like economy and other things which can get affected as well. This is going to become a problem. What if a particular region is extremely hot? All the food and the other items might get spoiled so soon, or the electricity bill might shoot up really high. And so it's in addition to affecting the natural parameters, it's also going to affect the economy and the other parameters as well. So this is one of the most important problems out there which is plaguing the humanity, and this has to be addressed as early as possible. And we are fortunate enough that AI has got a lot of tools and there are a lot of use cases of climate change which can be solved through AI. So in this use case, I'm going to specifically highlight about a particular problem statement. So these are gases like greenhouse gases like carbon dioxide, methane, molecular hydrogen, nitrous oxide. These all of these greenhouse gases, when they trap the heat. The way they trap the heat is by absorbing the infrared radiation, and this does not. And because they absorb the infrared radiation, the solar energy directly penetrates the Earth's surface. This in turn leads to increased levels of temperature, which in turn sets out disrupting the other parameters in the natural environment as well. This whole parameter is called greenhouse effect. The reason why I'm highlighting this particular definition is because our use case is going to be relevant to the greenhouse effect. So it's important that you understand how this whole phenomena of greenhouse effect happens. And so there are a lot of ways you emit carbon dioxide. So you emit carbon dioxides, like, even if you train in the context of AI, even if you're going to train huge language models, then that releases a huge amount of carbon dioxide. You'll be surprised to know the carbon dioxide which is emitted by these Google, Microsoft, Azure put together contributes to around 30 to 40% of the entire carbon dioxide which is released in the world. So these data centers release huge volumes of carbon dioxide as well. So that is also a problem, which is turning out to be a problem right now. So in all the everything we do, we have to try to minimize the release of these greenhouse gases as much as possible. So in this particular definition is going to be related to the use case which we are going to deal with today. But for all of you, those who are interested, just in case you want to, so there are multiple other problems out there for AI for climate change as well. But if you're looking for use cases specifically to resolve as a private project of your own to take it up. So there are three categories. You have fundamentals, you have adaptation and resilience, you have mitigations. So mitigations is about, if you want to reduce something, if you can estimate something, then you can reduce something. And so these are kind of problems which comes under the category of mitigation. So adaptation is, how you can, a particular flood has occurred or a wildlife fires are occurred. So how can you adapt and come out of it? So those are problem statements which falls under adaptation and resilience. And there is also another category of fundamentals which relates to how the whole problem of climate change is going to affect the economy as well. So this is general framework under which all the problem statement falls under. This is part of This is part of an article which is released by Boston Consulting Group. So you'll find around 60 plus use cases which can be translated from this framework. So just in case, if you are interested in solving a problem for AI for climate change and looking for a problem statement, this is the place for you to go. You can pick out a lot of problem statements out of this and do a project of your own, because there are a lot of places where I go, university students are confused on, can you please tell us some real world problem statements which we can pursue and things like that. So they're looking for project ideas. So this particular slide might help you a lot. I would also recommend, in addition to it, watching a video from DeepMind, and where DeepMind has got a scholarship, and they give scholarships for people pursuing their master's degree, and a particular graduate, as a part of the program, her project was based on AI for climate change, and deep learning has captured a small video series about the girl. I just shared the series of it. So that is also a very interesting problem statement which she has dealt with. So there are very, very interesting problem statements out there. So yeah, this is the one. So
AI is a way to express my
So the Julia is a student who has won the scholarship in DeepMind. So she's also solving a problem statement. Hers is more about glaciers and the melting and things. So there are a lot of problem statements. Uh, yeah, hers is mostly related to the glaciers solving and this aspect of climate change. So the multiple problem statements there. Maybe Julia's story might inspire you to take up a problem statement and solve it on your own as well. With that being solved, let's get straight to the problem statement. This is a huge domain, so there are multiple problem statements here. But let's get to one particular problem statement and start talking about it, which is going to be estimating building energy consumption. In India, again, we do not have a very well planned, city infrastructures and things like that. And but still, there are certain cities like Chandigarh and other cities which are Ahmedabad, and there are certain cities which are very well planned out. And this may not be exactly applicable in Indian context, but it might be more appropriate for other Western countries where the infrastructure is very well planned, and even estimating the energy consumption of entire area is very possible. A lot of metrics can be measured, and a lot of a lot of active based on the insights which they get. There's a lot of backup, a lot of action which can be taken as well. So one such problem is about estimating building energy consumption. This is a problem statement which has been part of Women in Data Science hackathon in 2021. This hackathon, and this is I was one of the first place winners of this hackathon. So this whole session is going to be me explaining about this problem statement and how we solve this problem statement, and also giving you insights about what actually contributed to our winning solution. With that being started, we'll just head on to Kaggle and start discussing the problem statement. I've shared Julia's story in the Slack 2022. Yeah, I've shared Julia's story in the chat window. Please check it. So this is the Women in Data Science 2022 Datathon. So this whole problem statement is from MIT, Berkeley Lab, Climate Change AI, and a lot of organizations have come together to organize this Kaggle competition. So we've got a very interesting data set, 7 years data from anonymized data from multiple parts of United States have been collected. And we have a training data, we have a test data file, and we also have a sample solution on how it has to be submitted to Kaggle. And when you take the training data, when you look at the features of the training data, you'll find a lot of features which is related to the house. So if you take a house, what is the floor area of the house? What is the Energy Star rating? In India, we don't have Energy Star rating for houses as such. You might have, I might be wrong, maybe there might be planned cities which are coming up, smart cities which are coming off of late, might have such Energy Star rating. But the Energy Star rating is generally not present, at least in the locality where I stay in Bangalore. And so this data has been collected for 7 years data from United States. So there you have Energy Star rating for houses as well. So you have the year which the house is built, what is the elevation of the house, what kind of house it is. Is it a warehouse, or is it a school, or is it going to be a residential building? But this matters a lot because energy consumption might be very different for a warehouse compared to energy consumption for a traditional house. And you also have a lot of features which are related to climate. So if you see what is the maximum temperature, what is the average temperature, what is the minimum temperature, how many days it has been above and below a certain temperature, what is the wind speed, fog. So there are a lot of climate related variables in addition to variables which are related to the house or the building. So this energy, energy consumption is going to be contributing to 37% of the factors which affect the climate change. So if you can estimate this energy consumption really well, then when you know so much of energy is getting consumed, then the second step would be how you can reduce this energy consumption. How can you plan the architecture of the city in a better way so that the energy consumption of the entire city comes down? So there are a lot of other decisions which can be taken out based on this estimation. That is why this estimation is very, very important. So this is the data set which we have been given. And I'll just walk you through a basic starter notebook on how to solve this problem and how to approach the problem. And post this, I'll get started with what was the exact winning solution of this problem. So the goal here is to estimate the building energy consumption, and the data set we have been given. We have given the training and test data set. And so here, this is a baseline notebook. I'll share this baseline notebook. Kaggle. So this, I'm just taking my training data set and test data set. I'm using importing libraries like Pandas, NumPy, Matplotlib. I'm taking my training and test data set, converting it into training and test data frames. And so if you see, there are 3 categorical variables. I have state factor, building class, and facility type. Out of the 64 variables, I just have 3 categorical variables. And the remaining are all going to be my numerical variables. So all of you will find the notebook in the chat window. You can just click on the notebook. You will find the, notebook in the chat window. Please check your chat window. I would also like to inform I'm unable to turn the camera on because my laptop is a gaming laptop. So it is primarily for running training models. So this doesn't come up with a camera feature. So I'm unable to turn it on. But yeah, maybe next time I would shift to a different laptop.
No worries, Usha, no worries. We're more interested in the things that you have to show, right, guys?
Thank you. So all of you have access to the notebook by now, right? So you want the problem statement? Yes, I'll share the problem statement as well. So there is a current women in data science competition which is happening, and that is also related to problem statement. After this, I'll also explain that you just have, I think, you just have 2 more days for the competition to end. So it's already pretty late if you haven't joined that current competition. But I'll say anyways, as a problem statement, if you're looking for ideas and project ideas, I can share, talk about the current competition, which is 2023 competition, which is also related to climate change. And this is 2021 competition and 2022 competition. And so this competition, again, we have been given a data set. We're using Pandas library to convert the CSV file to a Pandas data frame. Pandas is a very good data manipulation library. It comes with a lot of features. A lot of you might already be familiar with it. And it's also a very easy library to get started if you are not if you're not familiar with data science, and if you're an absolute beginner, you can get started with very quickly. It's very easy to learn library as well. So we have 64 features, and out of which 3 features are categorical features, and they are state factor. See, these states are anonymized, and which state these are from, building class, what kind of building it is, and what kind of facility it is. So these are the features which are categorical features. The remaining are all going to be numerical features. So we have a pretty decent data set. We have around 75,757 rows. It's a pretty good data set with a lot of data. And the current data set, which is 2023, has huge volumes of data. We have around 3 lakh, 4 lakh, close to 4 lakh rows. So this is somewhere around a moderate size data, I would say, in that aspect. And the data has some missing value. So as with any data set, you start cleaning your data. Cleaning your data is going to be the first process which you do, because the data in real world is not as very proper. It's always very messy. There are a lot of fields which are missing. There are a lot of features which will not be in a proper way. You have to derive useful features from certain features. So cleaning the data takes about 80% of the time. Getting your data right is the most most important step. So that being said, the first step is we explore if there are any missing values in the data set. Yes, this data set has got a lot of missing values. And what to do with this missing values is will come up next. And before that, you can also do the other things like checking out the statistics of all the numerical features. What are the mean, median, minimum, 25% percentile, and all this. Capturing this descriptive statistics of numerical features will also give you an insight about how the features are distributed. If you prefer numbers and just looking at these numbers, if you can capture a lot of information, then that's great. But if you're not a person who likes to read information or insights from this kind of a tabular data, but instead you want the distribution of variables in a visualized form, then you can also go ahead, take these numerical variables, start plotting the distributions using matplotlib. You can analyze the distribution of each of these 64 variables. You can also try that out. But analyzing the feature distributions and during an exploratory data analysis phase will give you a better insights if you're dealing with erroneous, if there is any erroneous data which has been captured, or if there are extreme outliers. So you can handle these cases before you start your modeling. So doing this, checking out for missing values, analyzing the feature distributions, or all these exploratory data analysis which are recommended that you perform before you start modeling. And you also check the distribution of target variables when you start with the distribution. So the target variables, it's distributed between the range of 0 to 200. And are there any outliers? There are very minimal outliers here in the target value distribution. So this is going to be a regression problem because you are going to estimate the energy consumption of buildings. So this is a regression problem. So you can visualize the numerical variables distribution, and then you can visualize the categorical variables distributions. We have just 3 categorical variables. And if you see the facility type, there are few facility types which are having more data points compared to few other data types. There are extremely 2 of which stands out, which has got lot of data points compared to the other facility types. The residential versus commercial, I think it is almost, it's a better distribution compared to the facility type. And when you come for states as well, there is state 6 has a lot more data points compared to the other states as well. So just giving these data will give you a better analysis. So you can try to find out the frequency of distributions for categorical variables as well. With regards to the missing values, dealing with missing values, here in this notebook, I would have performed a very basic mean imputation. You can also try KNN and other imputation techniques. But here it's a very basic, replacing all the missing values with mean values. And the next thing, what we were going to do is you have certain labels. You have to do a label encoding. You have to take all these categorical variables and convert it into numerical variables. And so the technique which you do is label encoding. And so this, we have an implementation in scikit-learn, and which makes it very easier for us to take all our 3 of the categorical variables, converting into numerical form through label encoding technique. And once we do that, we have almost done with most of our feature pre-processing. Then we just go for feature scaling. We want to bring, since these features are at different scales, each of these parameters are at different scales and units. In order to bring a uniformity, we would do feature scaling, where we would bring all the features between the values of 0 and 1. And once we do all the feature processing, here in this baseline notebook, I would have chosen Light GBM. So Light GBM is a tree-based architecture. There are multiple other architectures like XGBoost and Random Forest, multiple other tree-based architectures which you can try, CatBoost. These are architectures which has been ruling Kaggle for quite some time, although now deep learning for tabular data is slowly coming up. Decision trees and tree-based architectures have always ruled the Kaggle leaderboard. So Light GBM is already implemented, so you can take Light GBM, and building a model through existing implementations is going to be very easy. You just have to import the library and then create a constructor and give the values for the parameters. And then once you create the constructor, then model object, then you can just call fit method, compile method, and you're done with the implementation. So what if you want to modify these, what if you want to find the best values of these hyperparameters of light GBM? So I have a light GBM model. There are a lot of parameters like using type, metrics, learning rate, and all these things. These parameters, I want to know the best values for this particular data set. Then you can perform hyperparameter tuning. So there are a lot of open source tools which are available out there to perform hyperparameter tuning. And Optuna is one such open source tool which is out there to perform hyperparameter tuning. Optima is very simple to use, and I've shared the link to the tool as well. So you can click on it and find out how you can use Optuna to find out the best possible values for the hyperparameters which you're planning to tune. So here I'm creating a study, and then I'll have to say whether I have to minimize or maximize my objective. And then you just have a corresponding like GBM tuner CV where you mention all the parameters and the value range. And then you start tuner.run. And then it gives you the values for each of these variables which you have mentioned. It gives you the best values and best recommended values. Then you can use these best recommended values to build your light GBM model. So this is how the tuning process works. Once you build your light GBM model, then make predictions on the data set. And after you make predictions, you can also find out the features which are, this comes with a variable called feature importance, which tells you what are the features which actually contribute to the prediction of the model. So there are certain features which actually contribute to the predictions of the model. And facility type, year built, energy star rating, floor area, boosting class, and all these features have actually contributed. So the feature building related features have higher influence on the prediction. So this is what this feature importance variable Insaid gives us. So most of these models comes with a variable called feature importance, which tells you out of all these 64 features, which are the features which are actually contributing more to the prediction. So you can also use Shapely values. This is a library, open source library, which is available out there, which will also give you the same information. Whichever you're comfortable with, you can use it. And then you can just make predictions on the test data set, create a submission CSV file and then store the predictions and then submit to the Kaggle. So this is how a baseline solution for the problem statement looks like. But again, this has been competition. So what did we do? We did use a lot of AutoML. Surprisingly, AutoML was one of the key factors for because of which we won this competition. And my teammates were actually working for an AutoML company called Prevision.io. So we had access to these enterprise level AutoML tools as well. We also used AutoML tools, other AutoML open source tools which are available out there. And we also calculated the lag. So you have we calculated the lag features for multiple variables, and it's a past of it. So the winning solution is a combination of feature engineering. We created a lot of curated features and we used AutoML tools. We blended these two multiple models which were coming out of powerful feature engineering and AutoMLs that contributed to the winning solution. We also used straight up the table tree based models as well, like GBM, cat boost. All of these models were used in the blending as well. So these contributed to the best score for us. So if you just quickly analyze the data set, a closer inspection of the data set will tell you some of the buildings had some history and some of the buildings did not have an history. So you have to deal with the buildings which have no history in a different way, and buildings which uh, you know uh, which had history in a different way compared to the buildings which did not have history. So this kind of analysis also was one of the turning points, since dealing with, you cannot have a same approach for dealing with both kinds of buildings, cannot deal it in the same way. So for buildings that did not have any previous information, what we do is we use lag features, and we also use some pseudo labeling. So this was a gist of how our feature engineering look like. We created a lot of features using multiple base used on based on some common sense. None of us were from any climate change related domain, or we don't do climate change for full time. Just reading these articles out there, and it's just based on common sense. We came up with a lot of formulas, and we created all these variables, derived variables. So there are a lot of trial and error. Some variables out of we created worked, some did not work, and some of the which worked, I've just pointed it out: some lag based features, rolling based features, delta based features, and group by based features. These are variables. We created like thousands of variables, and we tested each and every of these variables on what worked and what did not work. And from the feature importance, it was very clear energy star rating and facility types were one of the important features which was contributing to the performance of the models. When it comes for training methods, we just, as highlighted earlier, use AutoML libraries, linear regression, CAD boost, light GPM. Ensembling techniques, the ones which worked for us was a weighted average ensemble, a very basic technique. But we also tried out all the sophisticated techniques available out there, but this is what actually worked, the winning solution. So this is how the pipeline looks like. You had feature engineering, feature transformation, AutoML, and gradient boosting models. And do you do post processing and then ensembling of it? So just of feature engineering contributed really was one of the most important factors on why we won this competition. And ensembling, also had helped us a lot. And post processing techniques, we tried out a lot of post processing techniques, which also helped us a lot. And this is a gist of what we found. What did not work very well is sometimes certain weather related features did not work out well. Fancy imputation techniques did not work out well. Removing outliers did not work out well. Adversarial validation also did not work out well. So our basic single model was 18.5, root mean squared error. And with this, what I would also like to highlight is AI for climate change is just not about solving these use cases. There are also a lot of successful startups which are coming up, climate tech startups which are well funded, 5 million, 20 million, which receives grant for from a lot of foundations out there. So this is also an area where you can pursue your entrepreneurial journey and also make money while solving problems for society. So if you want to seriously consider that, please also think in that direction. And the call for action is, it's a field which is very interdisciplinary. So it's not just people from one domain who can actually, it's not just AI experts coming out there solving the problem. So there is government involved. So even if you do all these models, government has to pass laws, government has to take decisions, and there's a multiple players which is involved. So it's very important to bring people from academia, startups, public and private sectors, bringing all of them together to solve problems for the world. So it's not just the AI people, it's a very, very multidisciplinary field. And identifying early stage startups who are working in this field and encouraging them can go a long way in solving these problems. And we have to take measurable actions in order to solve. So we require more of a ground level work. And with this is the conclusion of the 2022 problem statement. I would also like to highlight 2023 problem statement, which is again related to climate change. So if you take this climate change 2023 problem, so this problem statement is related to, again, it's a regression problem. What you need to calculate is there is a lot of weather related features out there. So there is a lot of weather related features like temperature, precipitation, ice concentration, and there are multiple other terrain models out there, geospatial light and all that. With these, there are around 245 features. And with these features, you have to predict the mean temperature of 14-day window. So this is a time series forecasting problem. For a 14-day window, you have to, estimate a temperature, which is the mean of max and min value in that 14-day period. So this is what you will be estimating. So estimating temperature is the problem statement for which Datathon 2023. It's been 2 months since the competition is live. I'm not sure. You just have 2 days to go. I'm not sure if this is sufficient at this point of time for you to get started with the competition. I'm not sure how much you can pull it off in a couple of days. But this is going to be a regression problem. There are baseline notebooks out there. So I've shared a baseline notebook here, which you can check it out. So you can use these baseline notebooks to quickly get started. So this will speed up your process. Even if you just download the data, you can go to my baseline notebook, download the data submission, and you can just, submit it to this, you'll be able to, place yourself in the leaderboard. So you can use this, quickly. It's a deep learning for tabular data. So you will also find other baseline notebooks in light GBM and all that. So this is a very interesting, similar to the previous problem. This is also a regression problem. And so you can just give it a try and see where it goes. Again, Women in Data Science, again, it's organized by Stanford University. So you have a lot of very interesting prizes, but it's again last minute. But if you check out the prices, there are 5 prizes out there. But since we were the winners of last year's Datathon, we are not eligible to win the prize this year. So last year's Datathon winners are not eligible. The prior years and winners are not eligible. So, but you have 5 prizes. So you have like very good cash prizes. And if you're a high school team, you have to register separately there. And if you're all of the team members has to be a high school team. And so if that is the case, then you will win a separate cash prize. And if you're an undergraduate student, then all of your team must be an undergraduate, and you have special prize for an undergraduate and high school team as well, in addition to having 5 great cash prizes competition. So you have 2 days to go. Today is Sunday, so you can pull up some time to calculate this competition. I'm sharing the link to this competition as well. I've shared the notebook. Sample notebook has already been shared, and the Kaggle competition is also there. So what are the important things, analysts, what are the important things we need to consider to resolve any problem statement? So it depends on which context you're solving. If it's going to be a hackathon or a datathon like this, where the problem statement is clearly sorted out and solved for you on a data set which is curated and given to you, I think here there's maximum here in this datathon you're dealing with is cleaning your data, because the data has got some missing values, and doing some feature engineering and things like that, because this is a very curated problem statement for you in a datathon. But if you are going to a real world, and the most important thing is even defining your problem, getting clarity on the problem statement itself is going to be a huge task, because a lot of people here try hard to find a clarity on the problem statement and why they're trying to solve a particular problem. Getting that clarity is going to be a very, very important thing. Once you have the clarity, then how can you go with the data collection process, and then data cleaning and everything else comes. So defining your problem statement will be the most important thing.
Yeah, great, Usha. Thanks for the rundown, right? Inside the mind of a grandmaster, I believe.
Thank you.
So, we have a couple of questions. So, I guess we can pick up the questions now, right?
Yeah, sure. We can pick up the questions. Yeah.
Yeah, all right. So, the first question that is very interesting to me also, a person is saying that we have already worked on personal projects and projects that we are doing on our own. But since you have done a project in a group, how does the workflow actually happens when you're working with multiple data scientists?
When you're working with multiple data scientists, see, sometimes it differs from team to team. So if you're working in a datathon and especially in a Kaggle competition, so most of them will be in the initial stage. If it's going to be a 60-day window, if the competition has got 60 days, at least for the first 25 days, people will just solve problems alone. And so, they'll have their own creativity and own creative ideas to implement, and they'll solve the end-to-end pipeline all alone because people are distributed across the globe. Here, my co-competitors were from France. So at least for the first 25 days, we just solved the problems end to end on our own, so that we were able to implement our own ideas and intuitions. And after 25 days, based on whose code was actually contributing to the highest leaderboard position, those people were sharing what are the insights which actually contributed. Then we just started mixing our ideas and we started implementing for the remaining days. And then we started focusing towards the last 10-15 days. We started focusing on one person, doing all experimentation and feature engineering, and one person in post processing, and the other person building out ensembling pipelines and things like that. We would divide the work. So this generally is the flow we adopt whenever we team up with people across the globe. And if you do not team up right at the beginning of the competition, and if you're teaming up towards the end of the competition, then maybe like people generally team up with similar people who are already having higher rankings and leaderboard. So at that place, it's going to be just ensembling of models and trying to merge all the insights which disparate diverse teams have brought in. So that's how Kaggle competition works as is. But if you're taking a professional data science team as such, so it depends. So in an early stage startup like us, so we have interns. We generally have interns of 2 to 3 interns. So we start with a problem statement, and in the initial stage, all of them start reading a lot of research paper, because in the real world, the problem statement itself is not very clear. So to actually, validate our problem statement is clear and it's the right thing itself, we read a lot of research papers. So reading a lot of research papers takes up a lot of time, and post which we also see if our problem statement is already resolved by someone else or not. So doing that validation, and once we are very much satisfied that it's not been resolved before and things, this will solve you a lot of time. If a problem has already been solved before, then why spending a lot of time reinventing the wheel? You can take inspiration from the existing solution and then re-engineer it as well. And then so the work will, once the problem statement and clarity on the data set collection and all this is sorted out, then the work is generally divided amongst the team members. And then we just do the work and we work. That's how it works. But it depends on team to team. So maybe in a startup, this is how it works. For an enterprise level data team, there are clearly defined roles. They deal with huge projects with 40-60 people in a team, or sometimes 20-30 people. There are diverse stakeholders who are involved. Some people will be predominantly involved in interacting with clients. So there will be customer facing data scientists. And then once I get the requirements from the client, there'll be business analysts also who will be working with them, who will convert these times into requirement documentations and things like that. So there are multiple stakeholders involved in a bigger organizations, and there'll be multiple people if it's a bigger project as well. So yeah, it varies from team to team. So I'm just giving a generic idea on how it works.
Yeah, great. And Santosh here asking is, how could you arrive at the deciding algorithm? Like, suppose it's KNN on random forest, how can we decide which algorithm we are going to go with? So I guess, yeah, that is the question of the millennia, right?
Yeah. So you have to, there is no standard rule that a certain algorithm will work for certain kind of use cases. So you have to do a trial and error. So you have to, check out, you can just put a loop and then try out all possible algorithms in a single shot. And then, find out which is giving you the best possible, results. That is one way to do it. And also sometimes we ensemble multiple algorithms as well, so it's not like just a single algorithm which is giving out you the best score. So if you take our last year's winning solution, we used in the ensemble, we used light gbm also, we used cat boost also, we have used automl, so we ensemble multiple models together. So it is not just a single model which is giving you the best performance. So there'll be multiple models which are giving you a closely competitive performance. So we try to ensemble those models to get a better performance as well. So it's all trial and error. There's no standard rule or book out there saying, these are the models which always. But generally, if you see, most of the tree-based models generally work really well. So when you're getting started with the problem, you can start with tree-based models are easy as well, because you're not going to write any implementation from the scratch. Most of the implementation of these algorithms are already available out there. You're just going to import these things and use these constructors and functions and APIs out there to solve your problem. So you're not implementing any algorithm from the scratch. So just get started with tree-based algorithms. This will give you a better insight on how the tree-based algorithms are working out. Post which you can also try, if your data set is big enough, then you can also give a shot at deep learning for tabular data, because deep learning for tabular data really works well when you have huge volumes of data as well. So TabNet, Tab Transformers, there are a lot of other architectures which are coming out as well. So this is my recommendation.
Hmm. All right. And Arjun Das, I hope that your first answer is already clear. It was pretty similar to that of Santosh. So I'm just going to take the second one. So Arjun is asking, what are lag features and feature engineering in general? And I also get this question a lot. So I would like, your thoughts on this as well. When someone is actually learning data science, feature engineering is like the most mystical topic out there, because that is something that you cannot directly teach. That has to come with intuition, right? How to create those new features out of the data that you already have. So why don't you take us through your mindset while you were creating new features? As you said, though those were very important for the model as well.
Sure. So when you take tabular data, so feature engineering is going to be very instrumental, especially in machine learning, because in deep learning, the feature engineering, the algorithm itself learns the features. That the neural network itself learns the features. But in tabular data, it's very important that you have to curate a lot of features manually for the model. So feature engineering, sometimes it's based on the domain knowledge. Domain knowledge, certain problems like the some of the hackathons which we have dealt with in the past were related to healthcare data. So the domain knowledge was very crucial in generating new features. So there will be certain values which will be present. You can plug those values into a formula and then derive come, because there are certain parameters which is actually used by clinicians, certain formulas which are actually used by clinicians in real world to derive. So if before AI was there, clinicians were doing it manually, finding out before a patient enters the ICU, they'll just read the report and they'll see if the patient has got ICU or not. How can they just go glimpse through the report and then decide the patient has got diabetes or not when the patient is entering the ICU ward? So they are able to do it because they were calculating certain parameters manually using formulas, and that's based on the values of those formulas. They are able to decide if this patient has got diabetes before he enters. So, what are the insights which the doctors actually use? Those features you can create derived features out of domain knowledge. This is an example which I'm giving you in healthcare, but this applies for every other domain as well. So you can also create derived features based on domain knowledge. That is one possible thing. And the other way which we generally do is we generally generate features like the mean values. Sometimes max value is generally a predictor, better predictor. Sometimes the mean values are better predictors. So we try to do, these are like a common process which whenever because in the beginning we don't know what actually works. So there is a standard template for generating features using group by related features, using rolling mean related features. There are standard templates. So we generate a huge bunch of features, and we experiment with each of these feature techniques which actually works and which does not work. So your feature importance will tell you like what are the features which is actually contributing. From that, you can actually find out some of the features would have worked and some of the derived features which you could create do not work. So that will actually fit. Lag features are nothing but a value one step before. So that is how you create lag features. You don't have to, go through any formulas, or you don't have to confuse yourself with creating lag features. There's also already a method which is available in pandas, which you can easily use plugin to create lag features. If you just go to a winning solution, we would have put a discussion post on winning solution in the Kaggle notebook. There will be 2 3 notebooks which we would have mentioned, where the lag features and everything will be mentioned as well. So check that out. And the exact notebook which actually contributed the winning solution has to be made public according to the rules of the competition. So all the 3 winners of the competitions have outsourced the public notebook. So if you just go and check out those notebooks and the write-up which we have written for the winning solutions, you will get how all these features are generated. And so this the for this problem statement, we would have used a standard template of feature generation techniques and just experimented how each and every technique which worked, which did not work. The ones which did not work, we would just drop them off. So again, just like how we cannot say a certain model always performs well, we just have to experiment with all the models and find out which works or not. In the same way, these are the standard template feature engineering techniques which is generally applied to most of the tabular data problems, and we have to figure out which works and which does not work as well.
Hmm. Yeah, I guess greatly said. We also say that feature engineering is sort of a trial and error thing. You just have to try a lot of things and keep experimenting with it, right?
Yeah, exactly.
Yeah. And there is another question from Sanjay. He's asking, can you brief us about a little what AutoML libraries are?
Sure. AutoML libraries are, libraries where you don't have to do anything, any feature engineering, any of the, implementation. So I'll just take through one of the my notebooks where I've implemented these AutoML techniques for one of the competitions. Yeah, this is a 2021 Datathon. So here, if you go to 2021 Datathon, so again, this is a notebook which I'll share in the window. So here I've put an AutoML libraries. So here I'm using an AutoML library called Dabble. So this is an AutoML library for doing exploratory data analysis. So I showed you the manual exploratory data analysis, which you can do in the previous example. So Dabble is very easy to use. All I'm doing is I'm importing pip install Dabble, then I'm importing Dabble, and that's it. So dabble.clean, it will automatically do all the cleaning. I don't have to mention what cleaning it has to do. I'm just calling the cleaning library, it will perform the cleaning. Then dabble.plot, it will give me all the plots. So, I don't have to specifically mention plot the categorical variables and things like that. And so that makes it easier. Like, you don't have to be a great programmer, and all the syntax like dabble.plot, dabble.clean, and all this is available in the documentation. These are not something which I have to write logic for. So these AutoML libraries are libraries which are friendly for even a person who's not even they're not a very expert in programming, who's just studying, who's a very strong, some people might be a PhD in a certain domains, but they want to try out certain use cases in data science, and AutoML libraries are a great platform for them, because they may not necessarily come from a computer science background or have some coding experience, but it's even friendly for those people. They can quickly prototype certain solutions without having to deal too much of without having to learn too much about ML, machine learning, and all that basics. All I did here was whatever is in the documentation, pip install, importing the library, installing the clean method, and then plotting method. I'm able to perform the entire exploratory data analysis with the 4 lines of code. And this 4 lines of code is also in the documentation itself. So this is a great tool for quickly prototyping if an idea is right or not, or if you're not strong with coding, this very friendly. It makes data science accessible to everyone. It's democratizing data science. And there's another tool called pandas profile. This is, again, I'm going to do a pip install, and then I'm calling the profile report method. It's just 1 line of code. I'm able to generate the entire profile exploratory data analysis for the entire data set. It's giving a PDF of the entire exploratory data analysis with just 1 line of code. So these are some of the examples of AutoML tools out there. There are multiple AutoML tools which you can use for modeling as well, MLjar, and there's so many out there. Suite is, and there are multiple AutoML feature engineering tools. So there are AutoMLs available for every part of the data science process and workflow. Yeah.
All
Hope
right.
this.
Great. I hope that solves your question. And I can see a very interesting question from Tushar this side. So, what will be the impact of ChatGPT on work in DSML and AI area? So, yes, why
Yeah.
don't you?
Yeah, definitely. This is a very interesting competition question. See, I've recently been in a lot of panel discussions discussing ChatGPT, and see, ChatGPT depends on how you use ChatGPT. I've generated a presentation for a particular webinar entirely using ChatGPT. So ChatGPT, you can't, it will not just give you a full page report just like that. You give one question. No. So you have to give the right kind of prompts, and you have to generate the PDF. So I had given, first I had a broad level idea of what I wanted to put in my presentation, but I was not a subject matter expert of a particular topic, but I had to give a presentation on the topic. And so I had a broad level idea what are the main gist of topics which I want to cover in the document. And I had given the right kind of prompts to actually generate the right kind of content, converted into a PDF. Then I added some diagrams from the internet, and I was able to put together a complete presentation for a webinar. So so ChatGPT is good, but it does not work for all the domains. In my use case, it was giving the right kind of answers. And fortunately for me, it was giving me the right kind of answers. But there are a lot of times ChatGPT does hallucinating as well, which means it starts blabbering and it gives you irrelevant information as well. So you'll have to be very, very careful. You can generate content using ChatGPT, but ensure you proofread it, read it well. So it's not always correct, and it may not always be correct for all domains and all questions. So you will have to use it really careful. Um, Outside this, there's a lot of other legal complications around ChatGPT as well. On one side, there's a lot of discussion. Even if ChatGPT comes up with interesting solution, it still cannot be made as an author of a patent. It cannot still be made as an author of, uh, you know, um, author of a paper, research paper, and things like that. And one thing which I also experimented was, in Chat GPT, I also tried generating certain codes for certain research papers. So it was giving me some kind of a template. So it eliminates around 20 to 30% of the work. See, the boilerplate template which you have to write, that is kind of eliminated. So you 25% of 30% of the code you don't have to write. It gives you all the boilerplate code. Maybe very specific, customized implementation specific to the research paper you have to sit and write. So it eliminates a lot of redundancy and boilerplate work. But again, you'll have to be extremely careful in proofreading it, because there are a lot of tweets and messages in social media which I've learned which ChatGPT have been performing terribly as well. So be cautious. For sometimes it works. So it's just still an evolving period. If this initial version can perform this really well, maybe in future they will keep optimizing it. And there's always this math GPT which has come up, which is extremely good in answering mathematical questions. There's also code GPT which is coming up. So there are multiple other variants which is coming up on the top of Chat GPT. These are interesting things. I'm really curious enough to try. I'm just looking forward for this math GPT open source version. So these are my thought process around ChatGPT. I'm not sure if I've really answered your question, but yeah.
Yeah, we are all unfamiliar with this at this point, right? Because this is such evolving thing. We just have to wait and see, I believe.
Yeah, yeah.
Yeah. And okay, guys, let's have the last question of today, since we are at the ending point. I'll just take Dravang's question. He's asking, I want to contribute in the environmental conversational using ML and AI and want to have this career transition. What is your advice on the next step in this direction? Which kind of institutes I should aim for, and how do we approach them?
Yeah. Um, so in terms of career transition, there are two things which I would like to highlight. What kind of learner are you? Are you a self learner who can learn everything by yourself? If you are, somebody who can you just use open source YouTube videos and sort out a plan for you, and study plan for you, and if you can stick to that commitment and learn for yourself, that's great. So if you are that committed person and if that is your style of learning, then that's great. But what if you're not able to stick to a curriculum? You already have, you are part of a lot of commitments, and you do not have sufficient bandwidth to sit and curate the content, and you're always confused in finding out what is the right content for you. Then it's better to join a full-time course, a diploma program, or a master's in data science program. I think Insaid itself has got a master's in data science program and other research programs out there. So you can join some programs because they have a lot of experts have spent years in curating the best content for you. And also at the time of completion, you might get a certificate of completion, which will be give you a very good credibility when you apply for jobs. But again, there is no hard rule that you should only go for these courses. If you're able to put a study plan on your own, just use the free open source materials available out there in GitHub, Google, and in YouTube, and learn on your own. That is also very good. So learn the basics. First thing is either through courses or self-learning, whatever is your style of learning. Have a study plan. Learn the minimum basics which is required. Once you've understood the fundamentals of implementing it into real world projects, go for problem statements and ideas. I've discussed climate change today. There are multiple other speakers who will be discussing on various topics. Choose some interesting projects and create a portfolio of projects. So by the end of the day, no matter how great courses you have, by the end of the day, what the recruiters are looking for is, can you apply this theoretical knowledge which you learned into a real world project? Can you translate that into that experience is what people are looking at. And so try to have very good projects on your portfolio that which will help you stand up from the crowd. Don't have projects like Titanic, MNIST, and all these things, and that can get you rejected as well. We were hiring from one of the IITs, and what we saw was the particular IIT has got a lot of winter school of data science or something that conducted, and almost every resume had the same projects from the winter school course projects were there. So please do not put such projects in your resume. have something unique. It doesn't have to be out of the world projects. You can take an existing project and just remodel it or re-engineering it, come up with interesting insights, or take a very common problem, apply a very different technique to it. So you just try to show small improvements as well. uh, so this is my recommendation, and diversify your portfolio. So right now it is in a very competitive, because for sometimes when we are at 12 people, we get 1600 applications, we get huge number of applications as well. So if you do not get a job, it doesn't mean that you're not skilled. It's just the field is a bit competitive. So just build your mental resilience and ability to handle rejections well, because there's a lot of rejections, and rejections does not necessarily translate to your lack of skills, but it could be a lot of other factors as well. So build your mental resilience skills, and keep trying, and perseverance, and keep putting in the hard work over a period of time will lead it to success, and will help you visual I mean realize your goals. So this is my outline, which I would recommend. Project, diversify your portfolio, not just projects. Have some public speaking skills, reach out to communities to asking for speaking opportunities, have some public speaking, local communities, speak at an event, go to some universities, give some workshops, and build your public speaking abilities. Be active in social media. You might do a lot of things, but you would never say it to the outside world. That is very bad. Start publicizing your activities in social media. There are a lot of people who just got job through social media as well. Apply, uh, have a very good GitHub repository. Whatever projects you do, put it in your GitHub portfolio, and then write blogs if that is of your interest, or you can create YouTube videos if that is of your interest. But have a diversified portfolio. I think this will set you up and right to land your dream job. So this is my recommendation, but there's no one size fit for all. So you have to cater it to your exact needs.
Yeah, great. Greatly said, Usha. I had the same words in my mouth as well, regarding that question. So yeah, really great. And with that, I guess, guys, we shouldn't keep her after the decided timing. So again, Usha, thanks for joining in. It was a really great session, and I hope that everybody learned a lot from it.
Yeah, thank you so much, Yash, for the wonderful moderation. I'm highly impressed by your skills in moderating the event. This is
Yeah,
one of the best
thank you.
moderators I've come across in recent times. Congratulations on that, and thank you so much for hosting me today, and thank you so much for the Insaid team as well, and thank you so much for the participants for turning up. And if you wish to, get connected with me, you can, just this is my Twitter profile, and because my LinkedIn is going to hit the range, I may not be able to accept connections after a certain point. So you can keep in touch on Twitter. And yeah, best wishes to each and every one of you, and hope all your dreams come true. Thank you. With this, I'm living. Yeah, thank you so much.
Sure. Thank you, Isha. Bye. Oh, my bad, my bad. Yeah, I've shared the feedback form, guys. You can just fill that real quick, and then you can move on to your regular sessions. Thanks for joining once again. Yeah, some of you might have your regular sessions. Just check your schedule once, and then you can move on. Yes, the recording will be available on your LMS as well.